Structural pattern matching in Python, not your average switch case.
Welcome to another video on smart architectural programming. My name is Mohammed and coding alongside me is.
It's George, and today we'll be going over structural pattern matching in Python. I'll let you drive, Mohammed.
So structural pattern matching is a feature introduced in Python 3.1 that allows you to perform pattern matching on data structures in a very concise and expressive way. It's similar to if-else statements, but like more in other languages like JavaScript in this case, you have something called switch case statements, right? They replace if-else statements to test for certain conditions when you have 10, 15, 20, or even more conditions that you want to test for. That makes if-else statements very cumbersome and difficult to maintain if you have that many cases that you want to work with. So in JavaScript, something called switch case statements is used. So recently in Python, not recently, but in Python 3.1, something called match case statements were introduced, and that could help us do pattern matching very powerfully. With structural pattern matching, you can destructure and match patterns in data structures like lists, tuples, and dictionaries, and more. And it's a very powerful tool for us to use for pattern matching and more. So let's start and first understand exactly how we can do that. So if you look at my screen, I have coded out a function and coded out some example usage for that function as well from line 10 onward. So we'll go over this function to understand exactly how these statements are used. So first, if you look right at the line 1, we define a function called match example, and within that function, we use the match case syntax to test for to apply this match case and pattern match case function, which we can syntax that we can use for pattern matching. So in this case, on line 2 we use match, the keyword match, along with value. Now, if you would notice, the input within the function is called value. So along with match, we always place the value or that we need to match for or test for in the cases below this, the match keyword. If you look at line 2, we use match and we're matching the value that is being input into the function when it's being used. So below match, you'll see we use the keyword from line 3. That's the first case, the keyword case, because that is necessary to set up different cases that we want to test for, right? If else statements, if this is this, then do this, right? So this is exactly the same. So instead of using if statements or elif statements, we use case. For example, here we're using case. In case 1, we're testing for the digit 1. So in case on line 3, you can focus on this. In line 3, you can see if the value is 1, then we print 1, and we exit the match case syntax that we set up here, and our function completes its cycle. Similarly, if that is not the case, then we move to case number 2, which is on line 5. Here we test for the string hello. If that is the value that was input within the function, then we print hello. And in the third case, if you look at line 7, we use an underscore here. Now, what is important here to understand is that underscore in the match case syntax represents default case. So if you're familiar in JavaScript with switch case, we use a default case there as well. If not, doesn't matter, we'll explain it right from the start. So default case is that if you don't have any case dealing with a certain situation, right? So if you have not written out or coded a case that deals with a certain situation, the output from that match case statement would always default down to this. The best way always is to include the default case to make sure your code does not crash. So in this case, if we don't have 1 or the string hello in the input, we'll always make sure that the code runs and it will print default. But if this case is not included and we run this function without the value being 1 or hello, it's going to crash, it's going to throw errors, and the code would have problems. So always use the default case. Now I'm going to run this code here on the console, and you'll see one hello default as a result for our example usage. So for the first one, we use the function with the value 1 and it output 1. In the second case, we use the value hello and it output hello. It printed hello on the console. And in third case, we put in the value 42, which does not match case 1 or 2, which is the value being 1 or hello. So it prints default. Now I'm not going to do this over and over again when I'm explaining this to the, explaining the other cases in pattern matching. But because you'll note that right next to these example usage, I've added the output on the console of these different cases. So you can look at that output and understand, what potential output on the console for the usage of that function would be. Now we can move on to the second case, which is sequence matching. Now, the way we're going to move in this video, now that you understand how simple match case syntax works and how you can use that in simple cases, we'll progressively we'll go in this video over more difficult usage of match case syntax to do pattern matching, so that you can get more comfortable with this tool in Python, particularly when you're exposed to the code that goes over different scenarios. You would become more comfortable in actually getting mastery over using this for pattern matching within Python. So the next thing that we're going to focus on is sequence patterns. Now, here the match statement is used to match different patterns in lists. So now we're going to match sequences within lists within Python to see how we can do that using the match case syntax. So again, we define a function on line 1, which takes an input value of seq or sec. And again, line 2, we use the match keyword and to tell the Python that we're going to match for the input value called sec that is being sent to the function. It's the naming is different, but it's exactly the similar to the value keyword input that we were using in the previous code that we went through. So case 1 is for on line 3 is for an empty list. If that is true, we print out an empty list. Case 2 on line 5 is for a list with 1, 2, and 3 being within the list. If that is the case, we print lists with 1, 2, and 3. And in case 7, we can case 7 is kind of like a default case. So here it gets slightly tricky. Like as I mentioned, we used default case on all of our code when we're using match case, so that we don't create errors in our code. But in this case, you'll notice we didn't use that for case 3. And the reason is quite simple, because even though we did not use the default syntax on this case, on case 3 here, the way we have set it up, the way this case is set up, it automatically is a default case. So while Python does not know this is a default case, this case number 3 here handles all potential all potential usages that would be going to be sent to our function. Now, if you're new to match case statements, I wouldn't recommend you doing that, because it would mean that you need to expect all cases to be handled by how you code out your default case. But in this case, as a simple example, and I needed to explain this aspect of match case to you, I'm just gonna show this to you here. So if you look at the square brackets, we're using x comma star rest. So here we're kind of destructuring the list that we're sending to Python. So x is going to be the first element that on the list, and star rest is going to mean the rest of the list. So here we're going to destructure the first element from the list that we're sending here and separate it from the rest of the list. That means if case 1, 2, and 2 are not true, any list that's being sent would have its first element separated and the rest of the list separated. So it's going to default to true for any list that's being sent to this function here. And if that is the case, we print the first element that we destructured from the list separately, and then we print the rest of the list that we rest of the list from which we separated the first element. Now, if you look at lines 11, 12, 13, we have the example usage. On line 11, we test for an empty list, and you can see on output, we see an empty list that is being printed because case 1 matches to this usage. In line 12, we test for a list, and we run the list 1, 2, and 3 within the function. And you look at the output here, it matches the output that we'll get if we print case 2 on line 5. And the third one is a random list that does not turn true for case 1 and 2. But the thing is, our default case handles this, so we get the output as we described above. Our default case would push out. Now, I can change the figures here to whatever, and it would still hold true because we are working with a list that we're working with a default case that handles everything other than the two cases we discussed above.